All right, my dears, the next thing we're going to talk about is indicators. Now, in the lab, we have a couple of options. So we can watch for the endpoint or the equivalence point using a pH meter, which is the most accurate way to do it, or we can do it using an indicator. Now, an indicator is a species that is two different colors depending on whether it's in its acid form or base form. There is a list of these things on the wall in the lab. It's on the north wall, and it talks about, what color is it in acid, what color is it in base, where's its pKa. Because in order for us to be able to use it as an indicator, we need to hit that titration for that acid base, the indicator itself, after the equivalence point for whatever we're trying to look at. And so it has to come after the fact. Now, depending on what indicator we choose, it may not be that close. And so we're going to have an error that comes from that. So the error, each indicator has its own pH range over which it changes colors. An indicator can be used to find the equivalence point in a titration as long as it changes color in a very small volume change where the pH rapidly changes. Okay, so as long as it's happening in that really small region where it's just going, usually what will happen is that one drop takes it all the way past, and so then we titrate some of that indicator in that moment, and so we can see it. And that's why we want the faintest color change that we can see, because it's the closest we can get. All right. Now, our indicator choice can be critical. Now, I mentioned that depending on what we're doing, we may have a change that is not in a good place. So phenolphthalein, one of the common pink indicators, color change between 8.3 and 10. So if we want an equivalence point that's below 8, that might work. But if we're looking for something that has an equivalence point in the range of 5, that's not a good choice. Okay, so we want to find something that is at a point above, a pH above what we're talking about, or below, depending on which direction we're going, but is as close to it as we can get. Because what happens is we hit that equivalence point where we exactly have the same amount of acid and base added to the solution. And until we then begin to titrate that indicator, we have a gap because we don't know that we've hit the equivalence point, and we haven't seen the change in the indicator. So there's a gap there. We want to minimize that gap. And one of the ways that we need to minimize that is to make sure that there is a very small distance between our equivalence point and where that indicator begins to change color. Okay. Questions about that? Now, the other thing I said is that there's always an error, right? Because we know that we're looking for the equivalence point. And that's where the H3O plus is equal to the OH minus. But the end point comes when we've started to titrate the indicator. So it usually takes some volume beyond the equivalence point to get that to a point where I can see it. And so the difference between that end point and that equivalence point is an error. That's called a titration error. Okay, so it is something that does exist. You should be able to explain what an equivalence point is, what an end point is, and what we mean by titration error. Okay, so that's all I'm going to say about indicators at this point. I think that's everything you're going to need for that. I think the next thing, we have some sample questions, and I'm actually just going to walk through these. So I think you should be able to identify a titration diagram. So you looking at a diagram like this kind of picture over here, you should be able to tell me, were we titrating a weak acid with a strong base with a strong acid, or a weak base with a strong acid? Okay, and you should be able to tell that from the pH at the equivalence point. We want to know if that pH is above, below, or at pH 7, depending on what type of reaction we're doing. So if I have a weak base with a strong acid, would I expect the pH at that equivalence point to be above or below 7? And if it's a weak base, it's below, because it's the opposite of what I think it should be. You should be able to identify a polyprotic acid titration. So the 2 steps that it has should indicate to you that that's polyprotic. I may ask you how many protons it has and however many equivalence points you see. That's how many protons it has. In terms of those salts, you should be able to, if we say that we've added a particular salt to the solution, we need to know if it's going to affect that pH, and if so, how. Will it raise it? Will it lower it? Okay. We want to determine or define the difference between the endpoint and the equivalence point, which I just talked about, and what is an indicator, and what makes it an indicator, i.e. it changes color between the acid and the base phase. So that's what we need for that, okay? So those are the kinds of questions I expect you to be able to deal with based on what we've talked about. Hopefully there are no questions about that. If there are, you know how to reach me. So email, phone, WebEx, whatever, let me know, and we will be happy to talk about that, okay? So we are going to start talking about the acid lab in just a second. I will be right back, and I hope you guys are with me. Thanks.